I am Ansley and this is my second Fluent project. I'm already in the design modeler. So start by drawing the rectangle and then go to the dimensions, give the dimensions, put it at 100 centimeters, put this one at 50, right? And then I'm going to concept, surface from sketches, sketch 1 is selected. Okay, and then generate. And that's it for the design modeler. So this is the meshing part of the Fluent project. So what you want to do now is you want to right click insert face meshing, or do you accidentally put one already in here, but it should show up, and then you want to click that, click on apply, and yep, and then what you also want to do is click on insert sizing, click on the top, and click on the bottom, actually edge sizing. Right, yeah, click on edge, apply, element size, number of divisions, change to some number, capture curvature, no, behavior hard, and you also want to make another sizing here. You control click that, click on apply, element size, based on number of divisions, give it something like 70, capture curvature, no, soft, hard, and bias type, you want bias factor of 70 as well, reverse bias, except for this one you want to reverse the bias, right? Yep. And generate, and now our mesh looks pretty good. So now we're going to be assigning names to it. So we're going to here, right click on it, insert, click on that, go to create name section, call this the far out pressure, and click on that, insert create name section, call it the inlet, click on that, right click, create name section, call that the plate, and click on this, create name section, call this the outlet. So now I'm moving on to the setup. I already have it open here. So what you want to do first, you want to set the flow to laminar. Okay. You want to change your fluid to air. Put in the assignment constraint. So for this case, 1.2 and 1.8. Change and create and close. And then you want to see here. So yep. Boundary condition, and then double click on boundary condition, go to forward pressure, change it to symmetry, click apply, and then click close. And then you want to go into here, change your inlet. So the assignment says this should be at 2 meters per second. Click apply, click close. Enter an outlet. The outlet, you should prevent the reverse flow. Apply and close, and you shouldn't need to change the wall. Right, you have no slip stationary, and okay, it's all good. And then you want to initialize. Then you want to run the calculation. Number of iterations, I'll just do 150. calculate. And the calculation is complete. So you can see our scaled residuals there, and then from here we can show our plots. So we can go into wall fluxes and then wall shear stresses, skin friction coefficient, X director, and for surfaces to do the plate. And yup, that is our skin friction coefficient plot right there. And then next we want to go to solution, report definitions, new force report, drag, print the console, plate, drag coefficient, report, yep, wait, no, hang on, you have to compute it, do it all again. So drag, print the console, plate, compute. Yep, there is our drag coefficient right there. And that is pretty much it for the setup, right? Yeah. So now I'm in the results tab. So we want to show both velocity and pressure. So what we can do for velocity at a certain point, I'm going to call this V35, velocity at 35 centimeters. Point 1 should be 0.035, 0.035, and this should be the full length of our block here. Should be 50 centimeters, right? No, okay. Alright, there you go. Yeah, there is. Okay. And then you want to do it again for another one that's 7 to 5. Actually, here, I'm going to put another sample there. Click on line. Call this one V75. 0.75. 0.75. Full height. And yep. Samples 100. And then you also want to make a velocity contour. Locations, symmetry 1, velocity U, range, yeah, 110. Just like that, you have our velocity contour. And you can also add vectors on by going to here. Vector 1, location, symmetry 1, reduction factor. You can use this to change the sides. I won't. I think it's fine. Yup. See the vectors over there? And then now we have to make a line for our pressure. I'm gonna call this one the pressure line. Domains. It should lie across the entire thing. I'll turn this off for simplicity. And this. Hello? There we go. Okay, so just stay at 0, 0, 1, 0.1. That should be 1 actually. There should be a line at the very bottom. Okay, there is 0. That is 0. And there we go. Okay. Samples 100. Click apply. Now to create another contour for the pressure. Go at symmetry 1. Pressure, yep. Range global 110. that is our pressure. Now we can create a chart. Go to chart 1. Name this one velocity. Data series. Make this one 35. Call this one 35. Create new 75. 75. X-axis should be velocity u. Y-axis should be y. Right? Yep. Okay. And then we also want to create another chart. This is our pressure chart. Pressure. Our data series should be the pressure line. X-axis pressure. No, this is not pressure. This is for wall shear. Wall shear Y. So I want this to be our x-axis, and this one here is wall shear Y. And just that's our wall shear. And that would be it for the assignment, I think.